So a lot of times in statistics, you'll see distributions. But how do you read them? It can be a little difficult, but I'm here to explain. So this is a normal distribution. This is the most common kind of distribution, and the core principles of it are it follows this bell shape, and it's symmetrical. Compare that to a skewed right distribution. This is particularly meant to look like a chi-square distribution. You see, a core difference here is that the mean, median, and mode are all located at the same location on this one because it is centered and it has a peak at its mean/median. The peak will always be your mode, which is the most common point or most common value. The median is the middle value. If we said 1, 2, 3, 4, 5, all the way for however many data points there were on this side versus however many data points there were on this side, and it's not weighted by how far away it is from the mean or whatever, right? That's going to get us our median. And then our mean is weighted by how far away it is from the mean. The mean and the median will be at the same location if the curve is symmetrical, while they will not be at the same location if it is not symmetrical. A nice way to think about this is to imagine the curve like it's balancing on a scale. You see, the mean would be roughly here because this is where the graph would balance if we put it on a point here. Now, for skewed right distributions, you'll have to use what's called the interquartile range or some other metric of spread. But with normal distributions, we get to use this nice thing called the standard deviation. A standard deviation allows us to measure how far spread out the data is. It's calculated as the square root of the variance, or the sum of xi. Sorry, I'm also kind of doing this through my phone camera. Bar squared over n, or n, it can be n or n minus 1, depending on if you're using a population or a sample, but that's not the focus of this video. As I mentioned earlier, you have to use an interquartile range, or the 75th percentile minus the 25th percentile, the location of those, because that gives you the spread, and since it's not evenly distributed, you'll get some weird numbers for standard deviation. Thanks for watching. Have a nice day.